My name is Jayseelan. I work for PayPal as a payments platform architect. Today, I'm just excited to share how we built a near real-time financial reconciliation system that would process 1.7 trillion of annual payment volume with the accuracy of 4 nines, and you know, and reading and recording the reconciling the transaction record, from 24 hours to 15 minutes. Let me just go to an agenda. Over next 15 minutes, I'm just going to walk you through, what is PayPal? And again, what are we doing in the financial payment market? Then what is the critical problem we have resolved? And what is the high level architecture that help us to, resolve the problem statement? And what the business impact we have achieved? So PayPal is a payment service provider in the global market, and again we process 1.7 trillion payment volume across 200 global markets. So this translates, 26 billion, the transaction volume, across 430 million active accounts. To put this in a perspective, we approximately process, as an average 900 transactions per second, with the peaks significantly during the holiday season, like a Black Friday or Cyber Mondays. So, I mean, keeping this massive scale, and again, it creates a unique problem, the problem statement for us actually. Okay, how are we going to ensure the number of transactions that are being processed in PayPal, and again, that is reconciled and recorded and reconciled with all the systems, whatever I think we have. Okay, that's a problem statement we are going to solve. So, what is reconciliation? Uh, so, to understand the reconciliation, and again, every transaction I think that flows through our PayPal system, it is not only processed within the PayPal boundary, especially when it comes to card transaction. And PayPal acts as a payment service provider, and again, we just persist the incoming card transaction into multiple records in our internal ledger. In turn, I think actually we just take those transactions to our processor, and processor in turn process or clear those transactions with the network, and again, network finally confirm and fund the for a given transactions to PayPal, and in turn PayPal settles the transaction money to the merchant. So to give the high level understanding, okay, since there are multiple systems involved, one is PayPal. Within PayPal, multiple systems in actually that holds, that holds a responsibility of recording the transactions within the local data store, also create outbound file, and again sending it to our external processor, and in turn actually we get that acknowledgement and funding settlement summary from end of the day, or T+1 or T+2. And again in turn actually we need to match all these transactions and make sure that I think the transactions is not being lost, or no data discrepancy or financial discrepancy between each transactions. Okay, that's the primary goal of reconciliation. uh, and another thing is that we need to validate the financial record that exactly actually reflect actual payment that made by the customer. Let's assume a customer made $100 card transactions through PayPal, and these $100 transactions starts with the authorization, and again we just clear the transaction, and finally I think we settle the money to the merchant account. So this is what the reconciliation is all about. Now, why reconciliation matters for us? Okay, the first and foremost thing, you have to imagine it is a three-way matching problem. The first one is like, the PayPal internal ledger. The second one is the processor. I think they register the transaction in their local SOR. And finally, the network confirms whether the transaction has been made. So across all these systems and with the different timeline, yeah, we need to, we hold the responsibility of, the transaction start entered in our system all the way can actually be settled to the merchant. And again, we hold the responsibility of, matching each and every stage of the transactions, okay, with the data footprint I think what we have. The second aspect is that can we do manually reconcile this transaction? I think that is highly not possible. Why? Because the volume of the transactions what we process, and again manual processing is not possible. Then we need automated state machine with a high level rule engine, and again that takes care of actually like how the transaction is being processed with our external vendor, and what is the timeline by which we can get that acknowledgement and funding summary from our external vendor. Everything is highly configured, the automated state machine engine, and again that can help us reconcile the transactions. The third important point is that, and again the reconciliation system is needed unless otherwise that is needed for us to think what is happened versus what actually happened. Okay, I mean, that's important. More than anything, okay, since actually these are payment to financial transaction, and again we abide to the PCI DSS standard. That means every transaction that is getting recorded in our system, that is completely auditable, and again there is a regulatory aspect to the transaction at any point in time, and again we will be in a position to just bring those transactions, and again provide, and again when exactly that is getting recorded in our system, and when exactly actually like we just settle the money to our external account. Okay, everything is auditable, and that's when actually the reconciliation is really important for us. So what is the current gaps? Our legacy system is basically actually based out of end of the day batch processing system. Basically it follows a principle of a store and process mechanism. So that means throughout the day, the transaction gets accumulated in our the source of truth. So end of the day, and again our batch will just take all those records, and again it reconcile. Okay, that's a existing mechanism we have. When it comes to source, and again the source is not going to be the direct operational data store from the respective system. Why? Because in actually like that will impact the performance and the latency aspect of that OLTP system. Rather, actually we have that we had that ETL system. I mean, that just actually source the data from our Oracle Golden Gate, and again actually that process everything using the transformation layer. The problem with the ETL, of course, it is not the direct source of truth. And again, there is a transformation and formatting is involved in the entire ETL pipeline. And there is a possibility of, the data mismatch or data inconsistencies. The third problem with the legacy system, and again, we have, it experiences delay. Why? Because in actual, like we accumulate all the transactions until the end of the day, and then I think actually we just match, and again, finally, we just go to that account book, and again make sure that the account book gets closed. I mean, that's a problem we have. Okay, how are we going to solve this problem? And again, that is what actually the real objective of just going to the new age platform in the cloud, and again leveraging that AWS infrastructure. The first one is, the end-to-end data integrity across payment lifecycle. So first, what it means. So we need, there is a data integrity. That means, this is the record that gets into a real-time payment processing system, and again, all the way it hops, across multiple systems involved within PayPal. And again, we need to link all the transactions with the right identifier and with the right timestamp when exactly it is getting loaded. Then from there, actually like we need to match with all these outbound files, whatever we send it to our processor. In turn, I think whatever that inbound records, actually we are just getting it from either the network or vendor, and again we need to match those transactions. So that's the end-to-end integrity, should be achieved with the proposed solution. The second one is the automated state-driven match logic. So basically, we want to just move away from store and process mechanism to stream and process mechanism, and again that can help us reducing the entire reconciliation cycle. So how exactly we are just going achieved, and again that's what I think we are just going to look at the high level architecture, what we are going to discuss in next slides. The third important aspect is that real-time monitoring. So what if actually like there are some exceptions while matching the transactions across, within the internal system, or the records that are getting received from our external vendor that is not exactly match with the transactions which are originated in our local ledger. And what is the action item? So basically, actually, like we need to record these exceptions in case of not matching, and again then that goes to that operational team, and again we need to act on top of it. Okay, let's move on to the technical architecture. So the technical architecture that consists of four critical pillars. Okay, starting from data ingestion, and again that from what are all the source, I think we just ingest the data for the reconciler. The second one is how are we actually reconciling it? What is the process involved in reconciliation? The third one is the outcome of that reconciliation, how exactly we are just storing it. The fourth one is how the operational team that leverage all these reconciliation exceptions, and again they are acting on top of those exceptions. There are four pillars. So this is the high level, the technical reconciliation. And just to confine the scope, all these upstream payment processing systems are abstracted out. Okay, it starts with actually the real-time payment card processor. Basically, the real-time card processor is the EKS service, and again that receives the millions of transactions per day. I mean, it is expected to have close to 300 million transactions per day, and every transactions that flows through these real-time payment processing, and again in turn that is getting recorded in AWS DynamoDB, which act as a source of truth and OLTP data store. The moment I think we just record all these transactions into DynamoDB, and again we just actually leverage the DynamoDB the stream through Kinesis data stream. The moment I think it goes to the Kinesis data stream, the first thing is that the ordering is getting managed. The second aspect is that actually all these transactions are going via Amazon data firehose, where I think we just bucket and chunk all those transactions based on the different business parameters. And finally, all these transactions are getting recorded into AWS S3. So AWS S3 is going to be the secondary data store, from the transaction perspective, but act as a primary, data store for the file processing perspective. So from there, from there, our actual data reconciliation starts. So the first thing is that all the inbound transactions that are getting processed in PayPal, I mean, that is getting translated into the complete Apache in the complete the Parquet file format in AWS S3. The second aspect is that once these file chunks are getting translated into file, and again, processed with our external partner, whatever that inbound record we have, everything will get back to the S3. So when you look at S3, now S3 act as a source not only for internal transaction footprint, as well as actually like it holds all these external processed transaction, I think, that are being received into PayPal system as a inbound files. Now we have all these sources, I mean, that are consolidated within the AWS S3. Now, when it comes to data processing, we have 15 minutes, the event bridge scheduling batch. I mean, that goes and again, trigger our Apache Spark, AWS EMR cluster. I mean, that just actually go and again distributedly process all these transactions, that are that are already been translated in AWS S3 with the pre-configured, the rule engine. The rule engine is basically consist of the multiple the state graph. The first and foremost factor is that uh, when exactly, I mean, that particular transactions, I think we need to categorize, and again it reaches to the terminal state. And if the timeline, if the timestamp elapses, and what is that alternate step I think we need to do against the transaction. I think that's a simple rule. I'm just I mean, giving as an example here, but the entire rule engine is a little complex based on which market we operate, and who are all our external partners, and again what is the cutoff time by which I mean, we can just export the data to them and again import their inbound records to our system. So based on that, I mean, the entire rule engine gets configured. So the Apache EMR cluster is leveraged by these rule engine, and based on that rule engine, and again it matches the transaction. If everything goes well, then I think actually like it goes to that, again it will just write the the result of that reconciliation, again put it back to that AWS S3. From there, and again, we have, if at all any exceptions, that goes to AWS Event Bridge event, and from there, actually we have, I mean, that triggers that a Lambda exception enricher, that enrich the exception and put it back to exception reports back to the S3. Now, with this, I mean, the storage part gets completed. From there, actually we have that operational aspect of what to do with these reconciled exceptions. So since all these data is a flat, Apache, I mean, it's a Parquet file. On top of it, in actually, like, we have configured Apache Glue catalog. So through which, there are two aspects on top of this Glue catalog. One is, there is a Amazon Athena. So the operation team can go ahead and again query these data, I mean, using that SQL fashion. The second aspect is that actually we have that custom built UA portal on top of this, Glue catalog. And again, that can just depict what exactly happened with the reconciliation, and what is the state of reconciliation for a given day, or the given settlement, or given the partner. Okay, until that granularity, I think we can just provide to the operational team. So this is what about the architecture. And one important, there are few things I think I need to call about this architecture. The first and foremost, point is that our entire architecture is active. That means we are just operating across multiple region in AWS. Then when it comes to the recovery point objective and recovery time objective, and again both are zero in our case. So that means since it is both are active, And at any point in time, if the one region goes down, then another region can able to process the transaction. And there is a uh, I mean there is a there is a question, I think, about that in-flight transactions. All these in-flight transactions is also taken care, since I think we are just using that Amazon Kinesis data stream, and the DynamoDB act as a eventual consistent system in actually between these two regions. Then from actually, while we have approached this problem statement, so there are multiple options we had, from the technology and architecture decision standpoint. The first thing is that, actually, like, what is the need for AWS EMR cluster? Rather, actually, like, we could have used, a Redshift kind of uh, the data lake solution, wherein, actually, like, all these transactions can go to the Redshift, and again, from there, we can just write a batch, and again, we can just consolidate all the transactions and aggregate it and match. The match logic can easily be made. The reason why I think we haven't gone with that Redshift, one is the cost. The second aspect is that it is an extension to the card processing system. That means the every transaction footprint is already being available in the S3 data store. And again, we wanted to achieve it using that low cost solution. That's when that AWS, AMR cluster helped us in actually, like, realizing this problem statement. Let me move on to the business impact. So from the business impact standpoint, now the accuracy get improved from 3 nines to 4 nines. Okay, that's a accuracy improvement with the solution. The second one is the speed. Earlier, it took almost like 24 hours, for us to reconcile the transaction. At least, we need to wait until 24 hours to just get to see, what is the outcome of that reconciliation. Right now, actually, like, it is improved with the 15 minutes cycle. The another thing is that, actually, it is a horizontal cluster, and again, from the scale perspective, even if it is a 1 million transaction versus 300 million transactions, the overall processing time for processing all those transactions, since everything is going via the distributed EMR cluster, and the maximum time it takes, irrespective of the volume, it would be 30 minutes. That's a timeline I think, actually, we have. Another one is the risk reduction. That means, you know since I think we just realize these reconciliation within 15 minutes, so we don't have that potential fraudulent risk, I think, that can happen, continuously in our system until I think we need to wait end of the day. And again, we can just act, within 15 to 20 minutes. And again, what is exactly happening in our system or external systems, and again, by this solution. The last point is the cost optimization. I briefly touched upon, actually, like, what is the technology choices we have taken, and again, what is the reason for choosing that AWS EMR cluster for reconciliation rather than actually going with the data lake kind of solution. The another aspect is that even these EMR cluster and whatever that Lambda for enriching these reconciliation, everything is on demand basis. So that means it is not a continuously running a computing instance, rather, actually, as and when the inbound files are getting reached into our system, or as and when, we have that chunk of files that is getting accumulated within 15 minutes, and these computing instances actually will have its lifetime. And once I think the process gets completed, again, all these resources freed up, and that minimizes the cost, of the reconciling processes. So that's all about the data reconciler, actually, what we built in the AWS platform. So thank you very much for your time. And again, if you have any questions, please, reach out to me in LinkedIn or that email ID I have just given as part of this deck.